Infinity, a word we have all heard of, a concept that may seem easy to understand yet is so complex. A common way to think of infinity is to think of an infinity of numbers. Like if you start counting numbers, you can go on forever. That's the basic idea of infinity. But to better understand infinity, let's talk about some numbers. A googol is a 1 followed by 100 zeros, a number greater than the estimated number of atoms in the observable universe. Then comes the googolplex, which is 10 to the power of a googol, a number so big that it can't be fully written down even if we use the whole universe as a canvas. But these numbers are still imaginable. Maybe you can imagine a number even larger than a googolplex, with even more zeros. But there are numbers that are greater than human imagination. One such number is Graham's number, so stupidly huge that even thinking about it can melt your brain. If a googolplex were a grain of sand, then Graham's number would be billions of universes filled with sand. But even this is nothing compared to infinity, because these are all finite numbers, meaning they have an end. So just how great is infinity? To understand this, let's imagine a hotel. A hotel with infinite rooms. That goes on forever. All occupied by infinite guests. It sounds hectic, but the manager does her job and keeps things running smoothly. One day, the bell rings, and a new guest arrives. Can the manager fit them in? Well, yes, because this is a common occurrence in the infinite hotel. The manager simply tells everyone to shift over by one room. The person in room 1 moves into room 2. The person in room 2 moves into room 3. And you might think there's going to be trouble because all the rooms are occupied. But because it's an infinite hotel, this can happen. 1 can move to 2, 2 can move to 3, 1,000,000 can move to 1,000,001. So everybody moves down to the next room, which means that now room 1 is open and the new guest can be accommodated. This works because infinity plus 1 is still infinity. But what if an infinite number of guests arrive? The manager simply smiles. She tells every guest to move to double their room number. The guest in room 1 moves to room 2 moves to room 4, room 3 moves to room 6, and so on. Now all the odd-numbered rooms are empty, and they go on forever, thus creating 2 infinities out of 1. How is this possible? Because in the world of infinity, size works differently. Take the set of natural numbers and the set of even numbers. Even though the even numbers are a subset of the natural numbers, we can pair every natural number with an even number, 1 to 2, 2 to 4, 3 to 6, and so on. This means their size, their cardinality, is the same. They are both infinite, yet equal. So are all infinities the same? Let's compare the infinity of natural numbers with the infinity of real numbers. On one side, we have the natural numbers that go on forever. On the other side, we have all real numbers between 0 and 1, which also go on forever. They seem equal, right? But using Cantor's diagonal argument, we can prove otherwise. Take the first digit of the first number on the list and change it. Then take the second digit of the second number and change that. Continue this process diagonally down the list. The new number you create cannot exist in the original list because it differs from every number on the list by at least 1 digit. And this process can be repeated endlessly. This means the real numbers form a larger infinity than the natural numbers, meaning there isn't just one infinity, there is an infinite hierarchy of infinities. Some infinities are bigger than others. But infinity can also be viewed through the lens of the finite. Let's return to the infinite hotel. The manager likes to keep things precise, so she decides to check every single room. But can she check infinitely many rooms? Fortunately, the manager is very fast. She can complete her task in under 1 minute. She spends half a minute on room 1, 15 seconds on room 2, 7.5 seconds on room 3, and so on. Half, plus a quarter, plus an eighth, plus a 16th. The process goes on forever, yet the total time adds up to 1 minute. Infinity is paradoxical, confusing, and deeply fascinating. There is a scene from a show that explains this feeling perfectly and is what truly inspired this video. It offers a fascinating perspective on infinity. Let's recreate that scene. Pi, the ratio of a circle's circumference to its diameter. A simple definition for a number that goes on forever, without ever repeating itself, which means that contained within this endless string of decimal numbers is every other number. Your birth date, your phone number, any number you can imagine. It's all in there, somewhere. And if you convert these decimals into letters, then you get every word that has ever existed in every possible combination. Your name, the first syllable you spoke as a baby, the names of the people you love, your favorite book, your favorite conversations, moments of your life, good or bad, everything you will ever say or do, every thought you ever had, every mistake, every triumph, your entire life story from beginning to end, every version of you that could have existed, all of it, all of the world's infinite possibilities contained within this one simple circle. So the question is, when everything is possible, what will you choose to bring into reality?